Hi there, and welcome to my little video on my test facility I built to try out various solar devices and so on. And one of the first things I want to point out is it's on a 20-foot container. There's 14 panels up there and they're sort of hanging off the edge. The idea behind this particular mounting scheme was that one guy could carry the parts up there and put the things on by himself, which I did do. Another thing is you notice that the panels are no gap between the panels. What this is, it's a railing system that I'm having a look at that turns solar panels into a carport roof or a roof of some sort. And this particular container has been down by the ocean. It's a bit ragged. You see there's a little groove there. That's where the water comes out that goes around the edges of the panel. So, you know, add a rain gutter and you got a water system. The panels seal up by sticking some goo in between the panels, that same stuff you use to stick car windshields in with. Well, what I've got here is sort of an interesting collection of things. Let's zoom out here. And you can see that underneath the panels there's an extensive bunch of wires and wheelies and gears going on. What this is I'm testing also some Tego power optimizers. There's one right there. That's a Tego power optimizer, and I've arranged the panels and wiring such that I can have any combination of panels between 2 and 14 panels by merely plugging and unplugging things. Of course, you got the mandatory Australian safety must-have isolator switches. Oh, and organic shadow maker, otherwise known as a tree. Not every place in Australia has them. Okay. These are some batteries that they're lithium iron phosphate batteries that I got from a company that was going out of business. They were doing bus conversions apparently, and I've connected them up to a Dali Chinese-made BMS that seems to work rather well. It's a battery management system. This is a 200 amp one. It goes down to the individual cells and connects from a wiring loom. And of course, you've got the usual great big wires going over to a, in this case, NOARC circuit breaker. And here we have a Australian-made power inverter. It's Selectronics. That's an SP Pro. This is the biggest one you can get that runs on 48 volts DC. To gather sunlight, we have a Fronius 6 kilowatt inverter that's been modified to speak words of wisdom with the Selectronic. And soon I will have a droplet, which will go probably right there on that blank spot of wall next to the Selectronic, that will enable us to do something called power smoothing. What power smoothing is if the sunlight goes away, this inverter, the Selectronics, will come on at the level that this inverter was collecting sunlight before the cloud came, and ramp down over 12 minutes over a linear fashion. Quite a difficult thing to do, but the folks that switched in say they can do it, and we're eagerly awaiting their input, their part. over here I have you know, the standard fuse panel and so forth, an outlet, and down here I have some more solar switches. And basically what I've done is I've put leads out. Let's see if I can zoom in. You know, that one says it's connected to 3 panels, and you just plug the MC4 connectors together to get whatever combination. Like for instance, right now the Fronius is connected up to, get a picture here, connected up to 4 panels and 5 panels in series, for making a total of 9 panels. Easy to do. I can connect all 14 up in series or some combination of them, and easy to do. Down here is a Fangpusen, I guess I'm saying that right, and it is a knockoff of Victronics, and that's a 150 70 amp maximum power point tracker battery charger. And what this does is it operates the panels at their maximum power point. Panels operate best when they operate at a voltage and current level where they can produce maximum power. This is true of anything. It's like you have an impedance matching issue with anything you do, and maximum power is transferred when impedances match. Of course, a laptop computer is sitting on top of this Chinese-made pure sine wave inverter AC charger, and this box does almost what the more expensive boxes do. Unfortunately, when I went to use it, it shuts itself off kind of randomly, but it does make the power that it says it makes, and does make a fairly nice sine wave. Anyway, that's the nickel tour of my little test stand that I've built. Let's see if it'll wake up. That's a pre-charge thing to pre-charge the capacitors in this thing. And now we'll throw the big breaker. And push the button. Yeah, didn't push it long enough. Probably heard it go clank and come on. And let's turn some breakers on. This is currently set up in islanding mode. And this box, the Fronius, should wake up and start collecting sunlight. Right now it's a bit cloudy. You know, 10 minutes ago it's not. The Fronius is saying, I'm waking up. I think it's what state 593 is. It takes a few minutes to examine the grid. In this case, it's a Selectronics. It's this box making a grid, and it tells you some things on the front while we're waiting. It speaks words of wisdom. It, of course, says that you know, the batteries need a little something to eat, and that they're sitting at about 80%. Interestingly, there's 15 cells here, and Selectronics wants to monitor the midpoint of the battery pack to make sure it's a good battery pack. And I lied to it with some resistors because there's no midpoint on 15 cells. So I put a few little resistors in there, right there, to tell it there's a midpoint voltage that wouldn't ordinarily exist. Oh, and I did forget to do something here. Turn on the power from the DC thing. It might wake up, or not. An interesting aside, this box has what they call a pulse width modulated solar input. It's PWM input, and it appeared to me, I've got to do some more research with it. Right now it's unhooked from the batteries. But it appeared to me that the Tigo power optimizers made the panels operate at their maximum power point level, doing the same thing as that box does, and supplied a surprising amount of power. Yeah, well, I don't know why this is sleeping this morning. Usually wakes up by now. You know, probably forgot to do something or flip some switch or twist some knob. But there is AC power available. You know, oh, it's waking up now. It's making noises. You can hear it going clunk. And, okay, we're starting to collect some sunlight. And we're not collecting a lot at the moment. We're collecting just a little bit. Because right now, it's sort of kind of cloudy. You can see some clouds. It's sort of cloudy. There would be the sun right there behind that tree. When it comes to life, then we'll, you know, when the clouds go away, then you'll see some power come on up and so forth. But even with that, with the Tigos and this, it's collecting some power and putting some current into the batteries. Grab my little voltmeter here. Make the thing a DC thing. And whack it on the cable there. Well, looks like we're eating some power out of the batteries at the moment. Let me see here. With these things, you have to zero out the Earth's magnetic field on the Hall effect sensor to know for sure what's going on. Yeah, at the moment the inverter's actually, well, it's fluctuating. When it gets enough power, it's actually feeding the batteries. It's going back and forth. But the transition is pretty low, which is kind of impressive. Yeah, the transition's at about 50 watts of incoming power. And like I say, it's early in the morning here still. So there you go. I don't know what else to elaborate on or blather on about, so we'll conclude the video.